Well, good evening everybody. Please don't be pressed the record button. Half an hour later. Yeah. Cool. Well, good evening everybody, and thank all of you for turning up today. So this is QABC. So we are QABC, QA Beginners Club. Who are we? We were a group to be set up that was kind of in a niche area to help people understand what quality assurance and software testing are all about. You've probably heard lots of terms before that might go over your head. We're here to help you understand that from the ground upwards. So if you're unsure of your career choices and you think testing might be for you, we will guide you through it. If you're a bit more experienced but still new to it and you're still unsure of any terminologies, methodologies, testing techniques, etc., we are here for you. That's what we are all about. So just a few little ground rules. This is always a safe space to be. When you come here, you should feel as safe as could be. And it's also always has been and always will be a free event. So please come along. Everyone is always welcome, don't care who you are, please come along. Again, always please be respectful of others. If you do have an opinion, please speak up. We always love to hear feedback and your opinion on any subject, but again, please be respectful about it. But however, you do think something has crossed the line, something has been ill said, please come and speak to Ashlea, Ken or myself. Can't see who I'm pointing to, however, they know who they are and hopefully you'll know who they are. However, breaking these rules will ban you from further events, so please be on your best behaviour. And just on a lovely note, we are celebrating 3 years this year. Amazing. So thank you for everyone who has supported us all over the years. And for all the guest speakers, everybody, it's been such an honour to be part of QABC, and it's been going this long, and it survived COVID itself. So that is absolutely amazing. I hope everybody finds it useful and still, for future references, find it useful as well. So, as part of our retro, rather than kind of using a sticky board, if you would like to, using the modern technology, if you like to use your cameras and scan this QR code, this will take you to a retro board I have created. There are 3 sections on this retro board. This is to give us feedback, because we cannot get better or improve unless you tell us what you would like or would like to see. So the first one is start. Things that we should try to do better. We should try, focus on any improvements, good habits, what you'd like to see next. Stop, things that the team ourselves should stop doing. Maybe focus on any inefficiencies, any time wasters, people turn up, any bad behaviours, habits, stuff like that. Just let us know and put it into that section. And continue things that you like. Any things that you like us to continue with and that you're happy with, please let us know. And on that note, I am going to say a big massive thank you to Searchability for providing and sponsoring this event this evening. It's always an absolute pleasure. And I'm going to hand over to Ashlea to introduce. I'm sure I'll do that then.
So I'm just going to do a brief introduction for Abbey and Hannah, who have come along with me today to QABC. Obviously, as you know, I work for Searchability, and they work for a sub-brand of Searchability called Klickstarters, which is very relevant to QABC and what we do here. So I will let you guys take it away. Go for it.
So obviously at Klickstarters, we focus on graduate and junior entry-level roles who don't have too much experience, mainly with under a year. Maybe we've done a few courses, IT career switch. So we can help you focus on your CV building, personal branding, maybe help you with your LinkedIn, and we can pop you into roles that are suitable to you and your skills so far.
So So we have a team of people who focus on, well, initially what Abby said, so helping people get into the industry, whether that's testing, software development, anything along those lines. We have a team of people who focus on different areas across the UK. So Abby, as you can see, will predominantly focus on London, but she also helps out with Yorkshire, North West. Matt and myself, I do the Midlands, but we're always happy to speak to people from anywhere across the UK, link them with the right members of our team and help give you advice and guidance on how to get into the industry. We have really helpful tools on our website, such as CV building. There's tips on what the market's looking like right now, so you can get a good insight into the roles that are out there, how to help yourself stand out from the crowd. That includes personal branding, like Abby said, so LinkedIn is a fantastic way of doing that. And just really helping people get right into the tech industry, whether you are, like Abby said, straight from a degree or we wanted to switch your career or have gone down the apprenticeship route. So we're here to help with any questions, anything that you might have along those lines. Yeah, I think that covers pretty much who we are, what we do, and anything that we can help you with, of course. Welcome any questions from anybody, and we'll, of course, connect with anyone on LinkedIn too if they need our help at any point. Ash, do you want to?
Yeah, thank you, guys. So, all I've got to follow up with is just some roles that I work on across the North West of Manchester. I haven't got any junior roles live at the moment, but mid-level wise, what type of tech stack they look for and things like that. So I've got one at the moment based in Manchester, looking for a QA engineer. So they are offering a salary that can go up to 38k, of course, depending on experience. Whether you don't have as much experience as required for the role, might still be an offering for you, could just be at the lower end of the scale. At least for this role, you must have 1 year's experience, and they are looking for experience with tech stacks such as Jira, Agile, Azure DevOps. So it's always good to have a bit of background knowledge in things that companies are looking for in order to obviously get to that next step. Next one I've got is also a software tester position. Salaries kind of the same, so it's 38k. They actually have offices in Stoke and in Manchester. They require you in the office 1 to 2 days a week, and again, quite similar, Jira and Agile, but obviously they are working within the mobile and web testing space. So certainly good to, get a bit of background knowledge and experience on that if it's something you're looking to get into. Yes, and the last one, as you can see by the way from each slide, they have got QR codes on. We will put this online, but it'll help take you straight to the advert to get the full job description, details of the company and things. This company are looking for a QA tester. A bit more niche tech-wise, they just want someone that's really strong within their SQL experience. Based in Wigan, I want you to come to the office 2 times a month. Salary can reach up to 30k, yeah, so they all are within that region. Obviously, it's outside of Manchester, so the salary range is slightly lower, but that just shows the type of mid-level roles and opportunities that are out there to give you those first steps. And yeah, that's all for me with job roles.
I'm just going to switch. What?
It usually goes so much better, doesn't it?
Oh yeah, totally lovely. So, yes, no, I don't get any notes because it's showing the same thing on both, so let's see what I remember. All right, hi, I am Andy Grant. So I'm going to be doing a bit of a talk about what developers do before it gets to QA, because despite all evidence to the contrary, we do actually do some testing before we give it to people. It's a bit heckling from the back. So yeah, who am I? I am a principal software engineer. I've been working in the industry for 15 years, but I've been doing development or programming as a hobby since I was about 7 years old. I was quite lucky in that when I started out professionally, I got in with the extreme programming and agile scene here in Manchester because it was really taking off about that point. So I had a lot of exposure to good development practice in my formative commercial years, which was quite lucky for me. I founded my own user group, Manchester F#, which is a very niche programming language, which I was trying to get more exposure to, so I formed my own user group. I do work here at Code Compute Love, and you've probably seen me before behind the camera, because for the last year I have actually been recording, editing, producing, and releasing the QABC videos. So that's a bit about me. I kind of make the videos happen. Oh yeah. Caution, poorly defined terminology ahead. So I am a software engineer, which is a piss take to anyone who works in real engineering, whether that's electrical or civil engineering. The people who built the pyramids 10,000, 20,000 years ago understood engineering principles. They were well established back then. Software engineering has been around for less than 100 years, so comparatively, we've just about got to the point where UG has found that one flat stone bounces on top of another flat stone, and rather than being well defined, we're kind of mostly at the stage of lots of people on the internet arguing with each other about what things mean. So everything I'm about to tell you now, there is someone on the internet who is quite happily to give a well-balanced, mature, and grown-up rebuttal on the internet. Yeah. So let's take the temperature of the room. I did intend a larger group here. What do people think software is, or software engineers are?
People who build websites.
People who build websites, okay, yeah, that's one thing. There's also desktop apps, there's APIs, all sorts of things like that. Has anyone heard of any kind of automated testing things that developers maybe use? No? Okay. This is why I take the temperature of the room, so I know exactly how high I should be. Picture this. Okay, let's take a very high view of, there's a couple of different kind of levels, and some of you, if you've come from a QA background or if you're familiar with it at all, you might have seen the idea of of the sort of pyramid of testing before. So the idea of this is it sort of shows there are different levels of testing, there's different sort of groups here, which I'm going to be going into a bit of, and you get more of certain levels of testing than others. So we have a lot more unit tests, then we have integration tests, then we have system tests, then we have user journey tests. And that's how it's usually presented, a test pyramid. Although the scale is actually slightly out of whack, because if we actually went, at least from the developer side, if we went for something more like what it actually looks like, it's more like this. And consequently, most of what I'm going to talk about today, or a large chunk of it, is going to be about unit testing, because that's what us developers actually spend all of our time doing. Notice I'm using the term developer and engineer interchangeably here. Like I said, poorly defined terminology. Up until a couple of years ago, my job title was developer, and then the business decided it sounded more professional if we were engineers. But that is what we spend most of our time doing, and then the rest of it is just like a little bit at the top. So I'm going to be focusing on that. Right. This is a high-level overview of what a software system might look like. So this is actually one for a checkout at a till, at maybe an online shop or something like that. The idea is that we have over here a big nebulous cloud. That's the internet. There's a module that maps that stuff, big nebulous cloud, to actual stuff in our code base. Although we kind of think of software driving the internet, that's not actually true. The internet was developed to serve up documents. So the idea that you would actually interact with it and it would be talking to a computer program that does interesting stuff like e-commerce or anything like that isn't really what it was built to do. So there's a lot of magic that happens here. I describe that as a module. So module is a glorified term for a bunch of software which is kind of related, because we have a lot of jargon in software development. So we've got a module there for doing that mapping. We've got a basket for keeping track of stuff. We've got a checkout where you put the basket in, you get a total. The checkout has some other modules it talks to. One's for looking up prices and discounts. And they talk to databases. That's the things on the right there. Via some more wrappers, because databases also were never developed really to power websites. They had a business purpose beforehand. They were used for keeping track of data, running reports, that kind of thing. So once again, actually plugging them into actual piece of software to make a site happen. It's not something that they're really designed to do, so there's a bit more magic. Right. There's a couple of ways of grouping this. I already said that we've got kind of like the internet there, that's a big cloud. And I already said that there is a bunch of magic that happens there. So there's magic, and also if anyone has ever done any testing through a front end, they'll also know that it's very brittle. It tends to break a lot. So it's also not really tied with what we're interested in, so I'm just going to take that out for the moment. Over on the other side, I said there's a database, and I already said that they were also not designed to actually power a website, so there's also a whole bunch of, oops, jump there, there's a bunch of magic that happens there. They're also slow. So software, or computers, as you might have heard, they're pretty fast these days. Do an analogy. If a piece of software is working with something in memory, has to do something with memory, that's like, reaching across your desk to pick up the book that's next to you to have a look. If you need to go and look at it from a database, that's getting in the car and going to the library. If you're going to get it from an API from another company, that's like going to the library, only the library's on Mars. The time difference is absolutely enormous. So, although it seems very fast to us by human scale, it's actually really slow. So it's slow, there's magic, I'm going to take that out again. For some reason, this is skipping forward twice each time I click. All right, what are we left with? Basket, checkout, prices, discounts. This is what we think of as the business layer. This is the stuff that your company probably actually cares about. There isn't magic happening to wire up an internet to it. There isn't magic happening to wire up a database to it. This is actual business logic. This is what your company probably actually cares about. And like I said, we've got rid of the slow bits, so this bit here can run really, really fast. Unfortunately, it's probably not going to work without some data, so I guess I do need to have those wrappers around the databases back in. But what I can do, of course, is just actually put in something that looks like the database. Question?
What's an SKU?
Okay. That's not from computing. That is a stock keeping unit. So if you're working in a shop or whatever, items in the shop have a stock keeping unit. It's like a unique identifier to describe that item.
Perfect, thank you.
Okay, so I've got to put these repositories, like I said, technical term, repository is just a piece of code that wraps a database and hides the magic of it. So I need the data to come somewhere, so I've got to have those. But I can just replace them with something that look like them, so not real. They can just be faked. And I'm back to being nice and fast. In fact, if I'm making fake ones of these, I can actually control the data that's in them. So if I just have the business logic and some fake sources of data that I can set up some canned data in, what's the price of an A? It's 50. Instead of going up to the database, I've set up some canned responses. And then I stick a bit of code in front of it that wires that up and actually makes some assertions on it. Then I have a unit test. So this is actually a unit test, the lowest level of testing. And like I said, these are fast. Because we're not going up to databases or doing anything like that, if I have a simple unit case, say, I've got a basket with 2 A's, let's say for an SKU there, we've got an A, an aardvark. We've got 2 aardvarks in my basket, and I run it through checkout, and it gives me a price, and that will run in less than a millisecond, which is 1,000th of a second. In fact, it's going to be running down more in the nanosecond sort of scale, which is like 1,000th of a 1,000th. I think I'm getting that right. It's fast, really fast. And that means that I can actually run a whole lot of those. If I had 1,000 unit tests, they're all running probably less than a second. And also, because I'm getting rid of APIs, databases, things that might change, and I control all the data because I've got those fake repositories at the other end, that means that it doesn't matter how many times I run them, they're going to be fast, but they're also going to give the same result every time. They're repeatable. I've isolated any data, they're repeatable. And this means Like I said, we can have thousands of them. They're fast, they're repeatable. That means that I can actually engage in something called test-driven development. So test-driven development, all right, yeah, that allows me to, I don't have notes here, so I have to guess which slides are ahead. If they're all those sort of things, I can test all the things. It means that I can have thousands of tests and I can run them all every time. In fact, I can run them almost every single change I make to the system. I can run those tests. And as well as being fast and repeatable, that means that if I'm working on a different area of the system that I think is going to be okay, but it breaks something in another part of the system that I've already got in the test, I will know about it. I've got a safety net, so I can work safely in the code. I can be fast. I can be sure that the changes I'm making aren't breaking existing functionality, and therefore I can feel confident in the changes I'm making. And this allows me to do something called test-driven development, where I can actually move the writing of the tests right to the forefront. Instead of actually putting these unit tests on at the end, i.e. I've written the system and now I'm going to put some tests around it, I can actually put the tests at the beginning. So this is the TDD cycle. What did I hit there? And TDD cycle is red, green, refactor. Starting off with red, I write a failing test. So this is some test around requirements. Like I said, we've got 2 aardvarks in the basket. I put it in the checkout, and I expect it to cost £1.30. No, I expect it to cost maybe £1 because an aardvark costs 50 pence. There we go. It's a test. It's a test that when I put the basket through the checkout, it's adding up the price of all the items. Okay. There might be a discount involved. Okay, I put in 3 aardvarks. Now, normally an aardvark is 50p, but if I put in 3 of them, then I get a 20 pence discount, so it's going to be £1.30. There we go. It's a test which tests that I am able to put discounts on, and they work okay. And these are quick tests, quick and easy tests to write. So I can put in the test, and then I can get it to pass. So I have put in the test first. The system doesn't do the thing first. I write the test, and it doesn't work because maybe the code doesn't even exist. I might not have written the checkout at all yet. I'm literally writing a test. There's nothing that it says exactly what I want the system to do, but there's nothing there yet. So it doesn't work. It fails. Then I write some bare minimum part of the system, green, to get it to pass. I can do that quickly as well because I'm working on something small. The tests are always working on a small breaking change. And I can get it to green. And I say get it to pass, and I do mean get it to pass. I'm not trying to write good code. I'm not trying to write code that works well or its performance or anything, because it turns out that actually solving problems and writing code that is good are actually quite hard things to do, and trying to do both of them at the same time is almost impossible. So I can focus instead on getting it to pass through any means necessary. And then I can move on to refactor. Yet another jargon word, like I said, debs, jargon, all that. Refactor just means I go back and I just start making changes. And I make the code good. So this is where I actually go and make the code look good, make the architecture good, while keeping the test passing. So I've got a safety net already. I know that it works. The code doesn't look great, but it works. And I can keep it working whilst I get it so that the code is good. So at the end of that cycle, we have code that passes the test, and it's good code. And then I repeat. Write the next failing test, and we just cycle and cycle and cycle. And because writing and running tests is really, really quick, I can go through these, I can burn through these really quickly. And I can have a whole suite of tests that let me know that what I'm doing is continuing to work as I continue to build it out. And now I'm going to do a terrible, terrible thing. I'm actually going to try and do a live code demo and show you code, which is usually a bad idea, but I have reasons.
Nice.
Terrible pun. Oh. Chris would love it.
Respect. No.
Right, there's no way that this is going to go wrong at all.
Do you say we're doing a live demo? Just me.
Right, so, like I said, I'm going to show code, and you're not going to understand all of it because it's code, but hopefully you can follow and know what happens enough. And like I said, I have reasons. So, this is what we call an IDE, an integrated developer environment. Sounds very swish. And I have a quick test I've written here, sanity test. True is true, And you can see I've said that actually false should be true because I want to show that it's actually failing. So I've got green dots down the side here, showing that there's a failing test there. Like I said, unit tests are so quick to run that actually I can just get it running as I'm working in the IDE. Hopefully, please work. Yes, there, it turned green. Excellent. You can see it stopped failing. That's actually passing now. So I know that the unit test runner is working, and I've got tests. Excellent. I can get rid of this test now entirely. I don't care about that. Let's just make that go away. All right, let's go back to the example I was talking about before with a bit of an e-commerce thing. We've got a shop, we've got a checkout, and we've got some details here about this checkout. We've got some stock keeping units. We've got an A, B, C, and D. This is some example data, like an A costs 50 pence, B costs 30 pence, etc. But also we have some discounts. So if you buy 3 A's, you get 20p off. If you buy 2 B's, you get 15p off. Does this all make sense? Excellent. Yeah. I put in a couple of things to help myself, but let's start off with, let's make a test suite, which is just a whole group of tests, and these are going to be the checkout tests. All right. So, like I said, we want unit tests to be simple and small. Starting from absolutely nothing, what do you think the simplest test I could write would be? Like, don't think about it from a programming side. If you literally had the table with the word checkout scrawled on a piece of paper and stuck to it, and a basket with some stuff in, or maybe no stuff in, what would be the simplest thing you'd want to see just to see that it works?
That the correct discount?
Well, that's there will be a test for that, but that's jumping ahead. That's not the simplest thing.
When you go to the checkout, your basket is appearing. It appears with your items.
Okay. So what I'm thinking more is, how about we've got a basket with nothing in it. What should the checkout say when we run that basket through?
0.
0. Yep. We get a basket. Let's have a fact here. This is test program I'm using. Yeah. And now I find out that I'm writing on a laptop keyboard. All right, so I've got an empty basket. The cost is 0. Or the total is 0. Bash bosh. I can type, yes. All right. Is that big enough? Can everyone see it? Yeah. All right, so for this I need some things. I need to have a checkout. And that's going to be red underlined because I don't have a checkout. Yes, I haven't actually made it. I'm going to need to have an order of stuff. And this is a new order. And this has a new list of line items. And this is just like literally empty. So I've got no line items in there. So more shop terms here, you've got an order, you've got line items. You get line items in an order. Camera's dead, yeah. That's okay, we've still got all the audio going.
Cool, do it.
The batteries are playing up, I don't know why. Right, so I've got an order with nothing. I've got a total, so if I take the checkout and I ask it what the total is for this order, there you go. And that total should be 0. All right. Okay. Don't expect you to fully understand what's going on there, but can you all see, basically, a little bit, I've got a checkout, I've got a basket with nothing in, I put that basket through the checkout and ask it what the total is, and that total should be 0. And I'm getting a big red because I don't even have a checkout yet, so I haven't even made it. That code does not exist. So I will quickly make a checkout class. Class is an OO term for a module, i.e. it's just a place we keep a bunch of code. So I'm going to use checkout class there. That's going to go great. That's great. That doesn't complain more. But now it's saying that total, that doesn't exist. So I'll just quickly create the method total. And total takes an order and returns something. Now the test is going red because it because it threw an error. Okay. Simple thing to make it pass. I'll just return 0. It doesn't matter what order you put through, it's just going to return 0, and that test passes. Excellent. I now have a test that proves every single requirement I have told you it makes. It has, which is that an empty basket costs 0. Job's a good one. Let's ship it, and it's new Amazon. But that, all joking aside, that is a total valid start to it all. I'm back to green. I only have the one requirement that I'm actually asserting here, which is that an empty basket costs 0. So we're past the red phase. We're into the green phase. I might go, okay, so refactor. Well, I don't like some things. I don't like the fact that I'm just returning a 0. I know that I'm basically faking this. This isn't right. This isn't good. It's not really doing what it should be doing. But it's okay. Let's move on to the next test. What would be a simple next test?
Adding an item.
Adding one item. Okay, let's go back to that example data there. An A costs 50. Let's have a test that an A costs 50. So if I scan, if I've got an order which has one A, it should cost 50. Cool. Let's write that. In fact, I'm just going to copy and paste this because it's going to be largely the same. Although it needs a better name because it can't have that same name.
Other name.
An order with 1A. With 1A. Costs 50. All right. Okay, so I need to make some amends to this. It's not an empty list anymore. This contains a new line item, and it has an A and one of them. Yep. And then that should be 50. And that fails because, of course, the total is 0 because, well, I told it that we should always return 0. So I go back and I go, all right, yeah, okay, I need to make this pass now. Once again, get back to green through any means necessary. Okay, let's just go, all right. Fine, if the order has more than 0 line items, then I should return 50. There we go. If you put anything in at all, it returns 50. And I expect that to go green now. And now that's working for both those test cases. All right, if you pass it in an empty basket, it costs 0. If I pass the basket with an A in, it costs 50. Of course, if I pass the basket in with anything at all, an order with any items in at all, it costs 50. But, you know, baby steps, baby steps. And I go, well, this still kind of sucks. You know, I'm not doing anything with the order still other than counting the items. So let's go for another test here. Let's do something so I actually have to start doing something real. Let's grab this and go, all right, then let's do the same, but I'm going to pass in a B. And that should cost 30. You know, try and force myself to actually have to write some real logic. Cost 30. And that fails. Oh, that's basically, all right, so I can't really do anything here. I'm going to have to actually start checking what's in the order now to make this pass. Notice the first 2 tests are still passing. An empty basket and one containing an A still pass. This B one, no, that's not working anymore. Right. How am I going to make this pass? Okay. Alright, no, think about this. Alright, so if there are any line items, let's say, okay, the subtotal is 0. Let's start off with the subtotal being 0. Let's go and get my first line item. Let's get that first one, just so I don't end up writing really long things each time. So, if the line item that is in my order, if it has a skew that's an A, then that subtotal should be 50. Else, back here. Else, if this line item skew is equals B, then that subtotal should be 30. And at the end, instead of returning 50, I should just return the subtotal. All right. That's getting better. Come on, it's going to go green in a second. There we go. All right. Red, green, refactor. All right, this is getting also quite silly. Now, I know that I probably need to have a database or somewhere where I'm getting these items from. So I'm going to start pulling this apart now. I've got enough here now that I'm going to do some serious refactoring. First of all, I'm going to go, right, it's getting silly writing this. If it's an A, else if it's a B, then there's going to be a C and a D. And of course, in a real shop, if you go to Amazon, there's going to be millions of these things. I don't want to write out this big, long thing every single time. Also, I talked about the test being isolated. At the moment, all this is hard-coded. This isn't really separated from data. While I've been writing these tests, the price of an A is actually now 60 pence for an item. And I don't really want to have to change it every single time the prices change. So I'm going to do a quick thing here. I'm going to go, all right, I know a data type I can use. I need something where I can look up the price, I can look up string, and I can actually find a price off of it, or an integer off of it. So, first of all, let's go and put them up here. All right. Nope, that's hitting the cursors. It's 30. Boom. That's great. Then instead of doing all of that, I've set up a better data structure, and I can just go, you know what? Let's equals prices item.skew, boom, and get rid of all of that. Should still pass. It's still green. I have the safety net. I know that I was already in a working state, but I know it carries on working while I'm working on this. That's better, but I'm still actually setting all of these prices here inside the test. I'm just going to move those out. Dictionary. So they can be passed in. Let's just grab all of that. I'm going to set the tests so that they can take it there. And the empty case as well. Boom. That could go. Excellent. So I've moved all the prices out of the test. The test doesn't care about out of the checkout. Checkout doesn't know anything about the prices. Still not 100% right though. Or first of all though, one thing I do realise then, no, it's still not quite right. This is a dictionary, but I talked about repositories. So I'm just going to throw in another class here. What I really want to do is just go, and I need a repository, but I don't have a real database to hook it up to, so I'm going to call it a fake repository for now. And what should the repository do? Let's say get price for SKU. SKU. Yeah. Let us take this. Almost at the end of the code bit, I swear. Okay. Private fake repository. Sorry.
So while I'm just doing that, I know people are probably seeing this for the first time, but the principle of things makes sense.
Yeah.
So before, like it says, as Andy said, before this even comes up to QA, this has to pass everything when things go from one deployment to another.
Yeah.
So that's cool. Yeah. I very rarely see this, and it is actually a little bit interesting. So.
Yeah.
Andy, you know, when you finish this, can you just walk us through the steps of what
Yeah.
it means as well?
Yeah, sure. Let's go. Right. So, get rid of that. So this is kind of like, I've started off with something which is bad code, but it works. At least it passes the test. And I'm kind of now easing things in and out and massaging it into the shape that I want it to actually be in. So I've kind of got rid of this dictionary, which is a thing for looking up, turning like, in this case, a string, which is just like a string of characters, a sentence, into a number. And I'm slowly replacing it with a repository, i.e. a stand-in for what that database would be. So I'm going to carry on driving that out so that this is not even taking a dictionary. Bash bosh. And now I can change these to be new fake repository. And I'm probably not going to have enough. Oh, no, that works. Did it work? Has it been smart enough to put enough brackets in? Yes, good, excellent. Fake repository, come back here. Fake repository. Boom. All right, so that's got a fake repository in, but I know that that is not really a fake, well, it's not, it's a fake repository. It's not a real database at all. It's shaped like a database, might look like I'd like this sort of database thing to be, but it's not quite right. But I did talk about how I could fake the repository, like, so it looks like a real one. And I'm going to do this using a bit of magic again. I'm going to pull out what we call in C# an interface. An interface is just something that allows us to describe what something looks like. So I'm going to say, okay, I've got an interface for a prices repository. So I know what it looks like. And I know that a prices repository, just like literally I can get the price for something. And this fake repository, that does do that. But now, because I've described what that looks like, I can actually go in and use another piece of, another library we've got, which is called a mocking library. So instead of having to make this entire fake repository, which I don't really want because I don't want a fake repository, I'm only using it to make the test pass, I can instead go, okay, repository equals a fake prices repository. Boom. And now instead of all of that set up there, I can get rid of all of that. Why is that not working? I can get rid of all of that if I hit the right key, and I can just pass in that there. Oh no, I do need to actually make a quick change there. That needs to be just an iPrices repository. No, not one of those. iPrices, why is that not? Oh, I've got two eyes, that's why. No. That. And a fake library. It's kind of useful because rather than actually having to make a physical thing, I can make a fake, a mock. It's like, well, it's what it sounds like. It's not real, and I have a lot of control over it. So I can make a fake repository here, and I can say, well, if you're asked how much a costs, then that's 50 pence. I don't need to all that set up there. Similarly. Well, in fact, now that I've driven things out here, I realise this. I've got one test that tests that when I scan an A, it costs 50. And another, when I scan a B, it costs 30. Except I'm the one who's actually setting what these values are in the test, so there's nothing really different between these tests. I can put anything in. I'm passing in that an A costs 50, and I'm expecting that when I actually call it again, call the checkout, that it tells me an A costs 50. Of course it does, I've told it that. So I don't need both of these, I can get rid of that second one. And I can probably give this a better name now, which just says that a single item costs the item's unit price. Unit price. Boom. And now that entire fake repository can go because I've replaced it with the fakes I'm using from the library. All right. Whoops. That has probably been incredibly tedious. But what I've got to the point now here is that I've actually built out the core logic of the checkout. Sorry about that. Core logic of the checkouts, and yeah, if I pass it in the basket with a single item in, it gives me the price of that. I could continue down this route, making more tests for what happens if I pass in 2 of an item, and I'll build that out with further tests. But you get the idea, and I'm not going to make you sit here and watch me do that because we've only got so long tonight, and it's incredibly dull. But did the idea make sense? Yeah. Did you see that it was actually pretty fast to write a test, it was pretty fast to get it something to pass, and then there was a little bit of fiddling with it to make it good, and all the way through I've got working software. This is building every single time, and every single time that I get it back to green, all the tests that are in place, which are basically business requirements, are green. It works. It's passing those requirements, and I'm building up and building up. So traditional software development, you would give people a whole stack of requirements and tell them to go away, and they'd come back in 9 months or a year, and they'd give you one enormous bang. It all works. It only started working last week, but it all works now. Whereas this way we're working, it's fast. We're able to sort of build something, and we're able to put it in front of people and say, is this right? Really quickly. So this is why we do a lot of unit tests. But, like I said, I was performing a bit of a sin by showing you code, because one of the things we've done as developers, which is kind of bad, is we talk to people in programming terms. We talk to people from the business in programming terms, and then they start trying to talk to us in programming terms because they think that's what we want. They think we want to talk about databases. We want to talk about cookies and sessions and browsers, which is not great because we don't really want them to talk about that. We want them to tell us about the business logic and how that works. If you remember on the big thing I had there showing the whole software system with the magic at the beginning with the UI and the magic at the end with the database, we don't want the business talking to us about the magical bits. They shouldn't need to care about any of that. And so out of that, an idea came along. There's a couple of different strains to this idea, that actually what we should be talking about to the business people is in terms of the business logic, what we call the ubiquitous language. It's the language that the business talks in. The business probably don't talk about price databases. They just have the prices. So when we're talking, we should be talking about that. We shouldn't be talking in terms of, we shouldn't be showing them code. What we maybe, if we have to show them anything at all, is, talk to them about user stories. Like, all right, got a checkout. So like, here's a user story on top of this. As a shopper, I want to get the total cost of my basket so I know how much to pay. Sounds like a reasonable user story. There's some scenarios there. An empty basket costs nothing. Okay, given I have an empty basket, when I get the total cost, then the cost should be 0. That's something there I can put in front of a business person, and they should be fine with that. That makes perfect sense. It's English. I can go and do more of these scenarios. They're discounted items, so the total cost of some of the individual items. So yeah, given I have an empty basket and the following prices, there's some SKUs with prices. Scan a couple of A's, scan some B's. Now, the thing about this is, you might notice that there are green pips here as well. That's because this is actually a behaviour-driven development library. So, off the back of developers writing unit tests, which grew out of extreme programming, which is a whole methodology for developers. Not for business peoples, not for QAs, it's for developers. But there's a whole lot of other methodologies like domain-driven design, which are aimed at trying to talk to business. Like I said, we talk in English terms, we talk in English language. So behavior-driven development was all about tools like this, where you don't talk in code, you don't show code. The tests are written in English-ish sentences to prove that this is actually a real test. If I change that then, the total cost should be 129, then this is actually going to fail. Yeah, there we go. Boom, that's not passing anymore. So this kind of idea sprung up because there were some big arguments about TDD. But the guy who kind of came up with this idea of these testing frameworks where they would use things like this. This is called gherkin syntax, if you ever come across it, because the original framework this was designed for was called Cucumber, because, I don't know, reasons. This is one of the most popular. This is gherkin syntax. And like I said, this is all tied around English sentences. Now, behind the scenes, there is magic happening to wire up these sentences to lines of code. But that doesn't matter. This means that we can actually do we can actually present things in a more human readable fashion. And this led into the idea of acceptance test driven development. All right, so I can't remember what slide I've got next, but let's go back to the slides just in case it's anything useful. Yeah, no, let's not. Not quite yet. Okay, so behavior-driven development for developers didn't take off hugely, but someone then went, hang on a sec, what about for talking to the business? What about for QAs? We've already got people going in and you're getting 3 Amigo sessions where you're getting developers, someone from the business and someone from QA sitting down and discussing the requirements. What about if, out of those meetings, you produce stuff like this, where you're sitting down, you've got QAs, you've got people in the business, and you write out what the requirements are in English, and then that goes off to a developer, and that is now the test itself. They get that document, this feature file, and they write the tests to make that pass. Or they write the governance that actually links up. And one of the nice things is that you might notice that the same sentences are repeating. That's because behind that one there, given I have an empty basket, once that piece of magical code that matches that up has been written once, you can just use it again. In fact, it's one of the sort of dreams of BDD, behavior-driven development, was that actually, once you got to a certain level, people in the business would just be able to go away and write these themselves. You wouldn't even need the developers. Once you have enough of a library of these phrases, etc., they'd just write those, and that would be fine. You wouldn't even need a developer involved. Never worked. It turns out that actually people in the business aren't interested in writing specifications in weird English, which is a bit like a text adventure game, where you have to use the exact same sentence every time with no variation. But never mind. Now I will go back to the slides, actually. Going again, yep. But yeah, it led to acceptance test-driven development. So in this one, you get the QA, developer, someone from the business together, and they talk about user stories. So these are things that are already in the business backlog, things that people want. You know, we want to be able to check out your basket, and it's going to do totaling your prices and apply discounts and stuff like that. Excellent. Got to check out. That's a user story. You get those 3 people together and they'd sit down and they'd hash out that big feature list explaining how it was all going to work, and it's written in mostly English because we don't want to talk to that person from the business in computerese, so we write it out in English. We get that big feature, and we get all the requirements, and it's distilled into that spec file, that feature file, and then you can pass that to the developer, and they're going to go away and they're going to develop for a week, 2 weeks, however long you're usually doing these things in. And at the end of that, you know, they're doing developing, testing, talking to QAs, they're going to be testing. But at the end of that, that feature file is going to be all green down the side because all of the individual stories on that are now passing. So the QA is happy, you've got some actual code that shows it all works as accepted, as agreed. And then you can demo it to the stakeholder. And then you just repeat. And it actually dovetails in quite nicely because actually that develop step down there is where the TDD cycle comes in again. So it's like a cycle inside a cycle. This, the big outside one, that's probably a 2-week thing. Every 2 weeks you get together, you plan out user stories, comes down to the develop, and they go in the TDD is.
What is the TDD?
Sorry, test-driven development. That's that cycle there, test-driven development. Cool. So that's test-driven development and unit testing, behavior-driven development, and acceptance test-driven development. Where do we go next? All right, yeah. So coming back to this diagram here.
Sorry, I've got a question.
Go on.
So let's say you're faking out, like a repository, a database. What happens when you swap in the actual real database? Is that?
That's coming.
All right, sorry.
All right. So that's coming shortly, very shortly. So yeah, got this, got rid of the left, I'm faking out the right. But whilst your team is working on this checkout, there might be another team working on something to do with reward points for cards. And another team that is doing, I don't know, my account. Users are able to log in, and that's a whole big thing. And they're separate teams, so it's difficult to actually kind of work with their code because it's in flux as well. They're maybe based in different countries or in different parts of the country. I mean, it means less and less now that post-COVID and we're all working remotely. But the code is in flux, it's not readily available. What can you do? Fake it. I don't care about the rewards card thing, reward points or users. I'm just going to fake all that out for now because that's a completely different team. But yes, at some point, you do actually need to try putting these things together. So this is where we get to integration testing. Integration testing is just literally where you get all these different things and you go, okay, actually, let's make sure these do work together. I've been using fakes so far. I faked out a database. Okay, first integration test, let's put real databases behind it and check that, it still works as expected. Now, up to this point, these have been unit tests. They go really fast. We're able to run thousands of them. The developers are running them probably every time they're changing a line of code. What am I keeping clicking? But now we're into integration tests, and these are slower because we've probably got databases. We need to coordinate with that team there to actually bring their work and our work together. So this is probably happening in build pipelines. Same for that team there. But this is integration tests, and there's going to be far fewer of these. Like unit tests, we had thousands. We've probably got tens of thousands of them in a reasonably sized system. Now we're into a much smaller number. These are just tests to test that actually when we put a real database in or when we get the user store, the my account in or the reward points, they do still work. And that's all an integration test is. In fact, if you work on a small enough team, they might not even have integration tests. If your product isn't big enough that there aren't these different things that you want to try seeing that they work together, you might not even have them. If you actually get to the point where you actually try, and you got rid of all the fakes, and you're using all the things, now you're testing the system as a whole. And that's a system test. That's what system testing is. It's testing the system as a whole. We're not using we're not faking out things now, we've actually got real stuff. And that's the simplest form of system test. It's the most obvious one. It's like the system as a whole, we're testing it all. But there are other types of system tests. For instance, security, automated security testing. I don't know why, but every time you get a picture of a hacker, they always have a hoodie on. So automated system tests, once again, we're going to have this as something that developers aren't going to be running it on their machine, but it's going to be hooked up on your build pipelines, and maybe once a day it runs an automated system test, a security test, where it's going to do things like seeing if it can break it, if it can actually get in. What happens if it tries various cross-site scripting attacks or anything else off of the OWASP top 10 list of things? There's too many things for any developer to actually keep on top of when it comes to security. What happens? It's going to check if you're using outdated components. It's going to check if it can actually just reach random ports. It's going to test that if you put drop tables in as your name, you're not going to accidentally drop all the database tables. So yeah, automated security testing. It's a little out of my wheelhouse. I actually have someone else in the company whose job that is to come up with stuff like that. So there's only so much I can talk about on that. But yeah, security is such a big thing that you can't rely on individual developers to know everything about it. So automate it. All right, another form of system testing. So far, great picture, isn't it? It's not me. Great picture. Great thing. Up to this point, okay, developers been running it locally on their machine. QA's been running it locally on their machine, or they've been using it is on a test server or something like that. Okay, excellent. We know that it works when you've got one person using it. What happens when you have lots of people using a bear? What happens when you have a lot of people using it? This is where we're moving into performance testing. So, performance testing, most people think, oh, right, so it's testing how fast the site is, and it's like, not quite. There's different kinds of performance tests. Like, go for it.
Are these done after integration testing?
Yes. So, unit tests happen on the dev's machine. Usually that code, when it's committed, then goes up through a build pipeline, where the unit tests run again, just to make sure that the dev isn't trying to pull some shit. Integration tests are run, system tests are run. Probably off to the side, the system tests are being run. This is probably not happening as part of that build pipeline because you want rapid feedback. And when you get to integration testing and system tests, they can be quite slow. So this is probably happening out of band, as it were. This is probably kicking off maybe overnight or every couple of hours, something like that. But yeah, performance tests, right. So most obvious type of performance test is business goes, at what point will the system break? It's like, how many concurrent users will it take before the entire thing falls on its arse and dies? And that's an obvious kind of performance test that we hear people ask for. It's not hugely meaningful, to be perfectly honest. It's like, that's great. Normally, what you expect people to go is, okay, you go to your customer and you go, okay, everyone's got Google Analytics, hopefully, on their site or something equivalent. What is the most traffic you've ever had, legitimately? And they'll go, oh yes, we're a train line operator, and every time there's a storm or something like that, everyone goes to have a look at trains to see if they're cancelled, and our peak traffic is X number of people a second for an hour. And you go, excellent. Okay, let's take that and let's do 4 times that and run a test where we put 4 times the peak traffic you've ever had through the system and find out how fast it'll be for customers then. It's like, okay, coming out of the back of something like that, you'll be able to say 95% of your customers will get a response from the website in X milliseconds. So you can be confident that if you have 4 times the most traffic you've ever seen before in your entire 10-year history, it's still going to be working okay. Or it blows up. That's probably more of a problem. We should probably look at that. But that's more kind of useful kind of performance testing.
I think a kind of good example where a website can't handle performance is roughly where you see around Christmas time, like curries and game, where you see that kind of
Black Friday.
Where you've got, oh, you're now in a queue. That kind of means that website can't handle that amount.
Yeah, it's like a slight holding pain for people. It's like, you can't come in yet because we've literally hit the maximum. Exactly. And then when people start leaving, we'll bring more people in.
Yeah, so again, as Andy was right to say, once they hit that performance,
yeah.
The best analogy.
So, I think in summary, I've talked about unit tests, lots of those, some integration tests, acceptance tests, system tests, including performance tests, security tests. So, one last one. Up until now, if you remember, every single time I've gone, let's ignore that left bit there, which is magical, where the internet comes in, people go through browsers and stuff because it's magic. At some point, you do need to do that, and that's what we call user journey testing, and that's where you actually have tests that go through the browser, and they are the slowest. Like I said, that databases are slow and APIs are slow on the right-hand side. Going through the browser is the slowest. Like, you know, it takes, a good site takes 200 milliseconds to load. If you're actually going to write a test that goes through the browser and tries to do things, it's going to be slow, so you can't make them. Also, if you've ever used the internet, you'll know that sometimes, just for no reason at all, it doesn't work. You hit a page on the browser and nothing happens, you get a blank screen, and you sit there a couple of seconds and you're just like, maybe I'll try reloading it, and it works fine. You're just like, that's why we don't do many tests through the actual browser. We've worked in places before where they've tried to test everything through the browser, and we've literally had test suites which took hours to run. And no one was allowed to touch or to try and actually do any work until that had finished, and then the next person could try and get their thing through the pipeline, and you had to wait hours until that one had passed. And it never passes because it always fails for some reason, because browsers' tests are brittle. And then you'd wait 2 hours, it would fail, and everyone would go, all right, should we try running it again? And it still fails, but for a different reason. So you go, do we run it again? And you've gone an entire day with no one doing any work. But there is some value in doing some of those tests. So what we do with user tests, key user journey, user journey testing is we go, what are the key user journeys? And for most websites, there's like, one journey they really want people to go through. This is the one that makes money. So we go, right, that journey. Test Amazon, you can put something in the basket and then you can go to the checkout. Boom, one single journey. We don't need to go through the entire recommendations engine, or what happens when you do this, that, the other, or someone goes to Prime Videos or something like that. This is your key user journey. There's probably less than 10? Less than 5? 6 max? Key user journeys that any website's going to have. So you only need to test those to the browser. And that's key user journey, and that's journey testing, and that's all you should really do with those. Automated tests, just a handful, 6 max tests, just to show that customers can go through, therefore the site can make money. Right, integration tests, behavior-driven tests, acceptance tests, unit tests, various types of system tests, user journey testing. So in summary, there is some evidence that the developers do some testing. Cool. Are there any questions?
So it's like it's a good valid point somewhere some stakeholders might say why are things taking so long. It's like, yeah, we're making, not just testers, developers are doing their best as well to make sure that their stuff is tested as well.
Like when it comes to QA, when the developers got it, it didn't even exist. It can't be any more broken than that. So we do quite a lot of testing first.
Yeah, it's not all about code. It's not all about building something. It's about making sure that what you're building, you build correctly. That's why you wrap it around with a load of tests.
Yeah, and like the acceptance test-driven development side of things, where you're actually going and getting the requirements, you've got the business there helping you get those requirements. So that is actually getting the business's line of, these are the things we want. We don't care about arrays and database and stuff. These are the things that we want, so we know we're building the right thing, rather than developers just going off and building whatever. Like, first test we did there was an empty basket costs 0. If we sit down in a requirements gathering session with the business and they go, wait, what? No. An empty basket costs 0. You can't even go you can't even go to the checkout if there's nothing in your basket. The option just doesn't exist. That's not a requirement. And you go, oh, okay. I mean, it might be technically true behind the scenes that an empty basket costs 0, but if the business go, that's an impossible situation, you can't have an empty basket. You just can't, we don't want that in the system. If the developer's spending time actually making an empty basket cost 0, it's wasted time as far as the business is concerned.
Makes sense.
Yeah. Cool.
Any questions for anybody?
I was going to say, so you base the unit tests for things that are not developed yet on requirements. So it's going to be...
So yes, before the developer runs off and starts writing unit tests, that Three Amigos thing should still be happening. Developer, QA, people from the business should still be getting together and talking. We usually have what we call sprints, better word would be iteration, mostly to set a kind of heartbeat to the work, and they are usually every 1 or 2 weeks, and that would be like the chance to get a bunch of people together from different disciplines to talk through what the requirements are. So the developers shouldn't be going off blind on this one. They should know what they're trying to build. So they should know that off discussion with the business. There should be tickets, probably being written by QAs or product owners, where they talk about what the requirements are as well, but at the same time, discussions should be had. Developers shouldn't be working in a vacuum. So yeah, although they're writing unit tests, they should still be aligned with the requirements. Cool.
That makes perfect sense.
I don't think Ken's planning on running his game anymore. I mean,
Which one?
I mean, you'll just be playing with yourself. I'm not sure we want.
What to do? I'm curious.